So hi, I'm Jonas. I'm the CTO in Monese. I was actually the very first developer in Monese back in the day. Before we launched, we had 3 backend guys and 4 Android engineers, and we launched with that in 2015. Quite a while back. 2015 we launched with 5 bigger services. One was the API that I'm going to talk a little bit more about today, and 5 other services split by domain. As the microservices architecture wasn't as hot as it is today, so the scene wasn't set. So we decided to go with 5 bigger dedicated instances. And as I mentioned, 3 backend guys and 4 Android engineers. So we were Android only back in the day. So now, 2019, we have 60 plus services. All the services are Spring Boot, Java, Docker, and Postgres database. If a service needs a database, it has its own. So we have around 100 RDS instances. So 100 databases to manage, quite a lot of overhead. You can imagine. BI people are very happy. Everything is built in AWS with a single gateway API that passes through all the requests. It's a RESTful one currently still, and all the requests go through that and get then proxied to a corresponding microservice. A little bit about the Monese also. So the teams, we were 3 backend, now we have 40 backend, and around the product and technology together are around 150 people across 4 offices. So this is one of our offices, one of the biggest ones. And we have an office in London, in Lisbon, and in Berlin. So London and Tallinn are big ones. Both have over 100 people. Berlin is a really small one. It's literally 4 people at the moment. And Lisbon, we have 1 development team and customer support, so around 40 people. All in all, 330 people. Why we started looking into this new API technology that we could use. End of year target, 1 million simultaneous users, meaning 1 million users using our application, either mobile one or a web one simultaneously. So quite an ambitious goal for us at least. Probably not for big players like Facebook or Google or YouTube, but yeah, for us still a big ambition coming from this three men and a dog company. Problems we are facing, like why can't we scale to this 1 million simultaneous users with the current setup? So very heavy endpoints. So I think most of you have seen this paradigm that the app developers want everything in a same response because it's easy for them. They don't need to query the backend multiple times, don't need to handle different error responses. Everything is nice, everything is fine. You can preload, you have data prefetched, everything is cool. Backend guys want to split it as much as possible, keep the load small, only load the data that you need, and only at a given time that you need it. So there is this constant fight between backend and frontend. How to do the endpoints, how to make them work quickly, and how to optimize them. So it's a constant struggle, and I think everyone who has dealt with that have seen it. This problem especially arises when you're dealing with mobile developers versus backend developers, because mobile developers, if you're a full stack developer, you need to build the backend and the front end yourself, so you need to know, what are the problems mainly in the backend, so you try to optimize it while doing that. But for mobile, they don't care about that. Mobile cares that everything is prefetched, everything is fast, you don't need to load in between states. So yeah, that's the problem. Gateway API, it's a RESTful one, as I mentioned. So this is still this one big monolith that we had that has quite a lot of functionality in it and does quite a bit. So it actually shouldn't, but we are still splitting it up. Gateway API is old, slow, and not RESTful. So as I wrote here, RESTish. So it's far from being perfect RESTful. And I think I haven't seen in my developer career this perfect RESTful solution. So if anyone has one, I would like to come and see that. I'm thinking that thing doesn't exist, only in those demos that you do. This is.
What do you actually mean by?
So everything split up by domain, nice small endpoints, very gradual. This is what I mean. So we need a solution. So we came up with, okay, let's try GraphQL. So we started exploring it. So far, we have been doing that for almost 6 months now. So it's a long project for us. And I would like to give some credit to our core team, Julia and Dersh, who are actually working on it on a daily basis. So they are the persons, if you want to ask more about the GraphQL, because I'm not doing that on a daily basis. So if you want to know more, they are the person you can go and bombard with questions. And if they don't know answers, then then they will find it out. So yeah, GraphQL, it's a query language for the API. So you can actually predefine your schema by defining the objects that you have, and then you can ask actually what you want. So you have these predefined objects, and these objects can have objects inside. And then when you query this, for example, you want this card with an ID, and you want this ID status and type field for that card, then you get exactly what you ask. You get this card with ID, type, and status. So that is exactly what you get. You don't get anything less, anything more. So if you need something more, you simply query what you need more. And this helps you actually to optimize the payload of the responses, and everything should be much faster. So yeah, what does this GraphQL give us? You get exactly what you need. So whatever you queried, you get that. You get many resources in a single request. That's what every app developer loves. I query everything I need and nothing else, and I can get it whenever I need it. So that gives them the ability to actually write lengthy queries if they need to. That has, like, for example, in our case, that has cards, accounts, transactions in a single query. So you can query it one time, and you get exactly the amount of data you need and exactly those fields that you need. And you have a single endpoint with defined types. So there is no multiple endpoints that you need to define. There is this GraphQL endpoint. You query this endpoint, and everything is queried. So all the GraphQL requests are post requests that contain a payload that has these defined types that you want with the fields. And then you can evolve your API without versions. So this is something I'm not 100% convinced that this is doable. And GraphQL guys claim that it is. You can deprecate fields in the schemas. You can add fields in the schema. It doesn't break anything. But it doesn't break in RESTful also if it's built correctly. But yeah, you can deprecate fields. That's a cool thing. So if, for example, if you have a object and you want to deprecate the field, you add an annotation deprecated to it. And next time app developer wants to use this field, they can't anymore. It shows them deprecated. So as soon as they have changed and all the customers have been migrated from the old app versions using the new ones, then you can actually get rid of that field, but not until they have done that. But for us, it's very complicated because we are supporting like 10 versions back all the time. So you can imagine the problem that you have, that you need to support 10 older versions, and everything needs to work, and everything needs to be backwards compatible. So it's very hard to achieve. So yeah. This is the sort of a pre-current situation. So this is where we started off with. This doesn't involve all the services that we have. It's simply, it wouldn't make sense to throw them all up. So I added some examples here to show what it actually is and how it looks like. So the gateway API is the center of everything. All the requests go through that. So mobile apps and the web app go through this API. And the API then routes these requests to different services and does it asynchronously when needed. So if a request needs more than one service response, it does it asynchronously. So it calls both services at the same time and then builds the response. We do have some services that communicate over message queues. These are literally left untouched because the queuing system still remains the same. So yeah, we are moving towards this queuing system more and more, doing this command-based asynchronous. So it's simply getting persistent commands. And
but how does the client get its response? So if then the data is behind the API where is aggregated asynchronously,
yeah.
And then this request waits till
yes, till everything is every service has responded to this gateway API and then it returns.
Okay,
so the slowest service will be the bottleneck.
Okay, with GraphQL you can also utilize a thing called subscription. So basically, subscription is a way to subscribe on the data that you requested, and then you can respond immediately with some placeholder values, and then as the data is collected,
you can pull it. Yeah. So GraphQL has different execution strategies that you can use, and it has this asynchronous one also. So yeah, I'm getting there. Don't worry. So yeah, this is sort of the proposition what the future should be. So GraphQL API and then services exposing their own GraphQL endpoints, and then the notification and everything remains the same. So this is the ideal world that we want to get to, and we are moving towards. So what else? So everything sounds nice, like GraphQL. You have different services exposing GraphQL, but the problem with that is that how do you stitch all of that together? You have different schemas from different services. And you have different objects in those, or different types when it comes to GraphQL in those schemas. But you have links between those types in different databases. So you need to build that all together. So how do you do that? So this was the next challenge. Like, okay, GraphQL looks nice, but it doesn't solve our problem. So yeah, we went even further and looked at a solution. What is the best solution we could use to do that? So yeah, it needs to that makes the communication easy between those services. So that was also one sort of a prerequisite for this solution that we wanted to build. And yeah, receive exactly what you need from those services also, not just from the gateway API. Yeah, so then we looked into and we found this Braid service that is built by Atlassian. It's a simple library that you can sort of plug and play. It has its downsides. Don't get me straight. So it has its downsides. You need to put quite a lot of effort to actually get it working. It's not as easy as it sounds. But yeah, Braid service. What Braid does is it builds sort of a schema of the whole architecture. So it pulls GraphQL schemas from different services and then puts them together and has the recollection of where this service is and what data it has. So it pulls together all the different schemas and then joins them. So if you have like account service and card service, and card service has an account ID in this card object, then it actually is able to link cards and account services together.
So it's like it aggregates your entire abstraction
yes.
to one.
Back to one grand monolith. Yeah. But it does that by actually querying it from different services, not this monolithic service. Yeah. So it puts this back to monolith. That's a really good analogy. I like that. So yeah, what you can do now is that with Braid, you can query the same card and tell I want account and this account status also and transactions. And it actually responds you an account with the status and transactions from a different service. So it does that automatically. Sounds also pretty cool, yeah? But it's not as easy as you can imagine. So what it does is exactly brings it back to one monolith. For the app guys, they see only one endpoint. Everything is nice. Everything works the same way.
But how's with security? For example, the one like this API gateway entry point.
Yeah.
You kind of consider it like open to the world. But
yeah.
Some services might be private for private use.
Yeah. That what we have done is with the API gateway is the only service public to the world. Everything else is private. Everything else is sitting behind the VPC. So what Braid service does is it actually creates these proxies of those services inside. And if you do a request that requires this new service, it does it in its own network. So the customer doesn't see, so the web apps or the mobile apps don't see where the service lives. And what the gateway API does is the authentication, adding a role to that request and sending it through to all those services with a role already. Okay. So this API does the authentication part and validation part, and whatever you want to do with every request that does that.
IAM role.
Yeah, IAM role. It says IAM role is an AWS base, so you don't need. So these are private roles. So they are sitting in the same VPC, so to say.
Okay.
So you have access to those, and if you want this to be separated, you can put it in a separate VPC and define what has access to that only. Okay. So, but this general gateway API has access to all of them, simply. So the tricky part with Braid is the instantiation. So this is the core of Braid. So how to set up Braid in a way that it lives forever. That's the tricky part. How do you set up Braid in a way that it lives even when you do deploys like 10, 100 times a day? Some of the services go down, come back up. How do you instantiate the Braid again so that it keeps living? It never dies. And if the service is down, it shouldn't bring the whole Braid thing down. So if one service is unable to respond, it shouldn't bring everything down. So that is the tricky part. So here you can see a really simple example of how to acquire a schema. So this Braid instance goes through all those schemas that are predefined. So these locations are defined, and it goes through them and tries to fetch the GraphQL schema from them. So yeah, what happens if it fails to catch, if it fails to collect this from this new service that it tried to collect the schema from? So what we built is, we built a caching in between. So it takes the latest version that it knows of that service and builds from that. So even if the service is down, the schema of schemas will not die on us. And it simply keeps living. So the Braid service is up and running, it doesn't die, and it simply instantiates from the previous working version. Yeah.
So the Braid is a running instance actually?
Yes.
Right?
It is running within this gateway API.
Okay. And then if the service is down for the Braid to get the schema information,
yes,
then the service might be also down to actually
yes,
retrieve the data. And
yes,
if it's really down, like what
if it's really down, then then there is this error handling in Braid that if the service is unresponsive, then it sends simply like if you have this like account object and then you have cards object, and then in this card object there is an error response. So these cards were unable to fetch. Everything else works. Yeah. So it sort of heals itself.
So for this down piece of information, it just returns the regular GraphQL error.
Yes.
Okay.
Yes. So it doesn't break the whole world, so to say. And yeah, it takes it from the cache. And then it takes this schema source map and then initiates the whole Braid schema of schemas and builds it. And then you need to store it in a singleton container. So this Braid service, so to say, needs to be the same for all the requests. So it's in a singleton. And then what happens if this service now comes back up? So this is not handled by default either. So what we did was we built a sort of a push notification that the service comes up, and as soon after the service has started, it pushes that, okay, I'm up now. And if Braid sees that, okay, this service with a newer version is now up, it actually goes and collects this schema again and instantiates the Braid instance again and creates simply a new Braid service in the same way, so replaces this one. So this is sort of a self-healing mechanism. So if services come down, services are deployed, each time a service is deployed, a push is sent that, okay, there's a newer version, it pulls the newer version and sort of self-heals itself and keeps going. So that is the magic of that. So challenges we addressed with that. So multi-step schema instantiation. So how to achieve that? We achieved that. Self-healing, as I mentioned, if a service comes back up, it pushes it, it heals itself, and then everything keeps working. And then schema reloading, this push is doing the reload also. So this is handled by that also. So challenges we're still facing. So this comes back to the topic that I slightly mentioned before, is this versioning. So how do you work in a dynamic environment where the services are constantly being deployed? There are two versions of different services running. Because when you do a deploy, you do a gradual one. You don't do a full bang downtime deploy. So there are two versions of the same service running. So this is the thing that we are still like struggling with, and the solution to that. Yeah, go ahead.
But this one perhaps is the same way you do regular zero downtime deploys. You just support an intermediate rollout first, an intermediate version that supports both behaviors, and then you. Spot
on. So what the idea is that the service is always backwards compatible. So the newer version must support the older one also that was already running. So when the older instances are pulled down, then this reload push is sent and the schema updates. So then you don't have the older version running anymore. So sounds very, very simple. So this is something we are still working on. So yeah, does this solve? But now big question: does this solve our problems? Does this solve the problem that we had in the first slides that I presented? Does this solve this one single point of failure? Yeah, actually, in terms of one single point of failure, it doesn't. There is still this now like very well said, that it's now bringing it back to one monolith. So we have this one monolith, and if this service is down, we have a problem. Luckily, this service is a very light one, so it doesn't do anything on its own, only the authentication part. So in that sense, yeah, it works. So the gateway API now is in a much better shape than we had it previously. Another problem that we had with this gateway API actually is this, as I mentioned, we have this multiple team setup. So each team were building their own services. They are responsible for their own service, and they deploy their own service. But the gateway API is one. So if you want to add proxy to your service in the gateway API, you need to actually deploy that. So imagine 13 teams deploying 1, 2, 3 times a day, adding new endpoints to the gateway API, and then some teams have actually added something that their service is not supporting yet, so you're in a lockdown, so you can't deploy it before their service is fully up and running. So it's a mayhem, so it's very hard to manage. And this problem is perfectly solved with this Braid solution. So whenever your service is up and running, it simply updates the schemas, and everything is nice and working. So this is one very good use case that we see, that when you have this multi-team setup, this helps against that. And if you don't, and especially if you don't want to open up the world to all your services. So if all the services are sitting behind a gateway. So this in that sense, it solves the problem. There are other ways you could solve that problem, like getting not using this dedicated instance for the API, for example. You can do different ways this API, this routing. But yeah, in that sense, it does solve the problem. So now is the part that we are at the moment. So we are now doing the migration part. How do you move all those services that are RESTful now to this Braid, a GraphQL solution? So this is a long project, and it has been taking us a long time. But luckily, what you can do is you can map the REST responses to GraphQL also. So if needed, you could have a RESTful service serving GraphQL. So in that sense, it simply takes the full response and only returns the fields that you requested. So you can do that, but it's not ideal. I mean, it defeats the purpose. So yeah, this is something that we are still doing, and it's taking us a long time. So bear with us. We will let you know what the end result is when we have fully migrated. But yeah, definitely I see that this is a new way of doing things in terms of the API, and it's going to be the future for us at least. So yeah, in that sense, I don't have any other slides to give you. Before we go to the questions, you see the positions here. We are always hiring, so if you're interested, yeah, you know where to find us. careers.monese.com, man. Any questions? Yeah.
Yes, there will be
plenty probably.
Yeah.
Well, I have only one, but basically one of the issues people who used GraphQL we found is performance. And I know a couple of companies they said that we will not use GraphQL because of degradation of performance and gRPC or whatsoever. But please no GraphQL.
I agree that it is a tricky part, because I was worried about that also myself. But to be honest, the problem with that is that developers that are doing that both ways, like backend guys and the front-end developers, they need to know what they're doing. If they don't know what they're doing, then you can make anything slow. If you know what...
GraphQL by itself, but nothing comes for free. An additional layer of abstraction when you have this dynamic model and so on. So it's...
A compute resource nowadays is cheap compared to if you...
Something opposite to what you said before.
Yeah, but I mean, compared to the hardest thing I have found during my days here is the databases. This is the hardest thing to scale. And the traffic itself also. The compute itself is simple to simply take some fields out, put back in. But yeah, the payloads itself and the databases are the hardest thing to scale. So if you have very well optimized GraphQL queries, then I don't see the difference in performance, to be honest.
And to me, it's actually the same level of abstraction that
Yeah.
that your any other like
Yeah, exactly.
is.
Because
it's just like an interface to.
Yeah.
to
One thing I didn't mention is that this GraphQL does not mirror your database directly. You need to actually define those types. You need to define how you get each single field. You need to define how you are able to filter those objects and how those queries are done to the database. So you need to define all of that. It's not like I'm going to take my database schema, I'm going to drop GraphQL on it, and I'm going to query whatever the hell I want. That's a different thing. That's called SQL.
But at the same time, if you talk about REST is more strict from a contract
Yeah,
perspective.
contract perspective, REST is a lot more strict. I agree, but as I mentioned before, fully RESTful is strict. As soon as you start adding stuff in the queries that in the responses that shouldn't be there. For example, we had this, like, give me this 30-day spending graph data. So it's like 30 days spending graph data coming back. Previous app versions are showing this 30-day spending graph. Now requirement is I need this 14 days spending graph. So now we are returning 30-day spending graph and 14-day spending graph because the old versions are not able to support this 14 days. So if you take that and if you leave this fully RESTful world, then it becomes a mayhem. So in that sense, GraphQL helps us.
Where does it hurt? Have you found any spots where it really hurts using GraphQL and you wish it would?
My biggest fear is that where this all actually started is that app developers like to get everything. Like I would like to get the whole world in a single call, and then I would never call a backend again. So this hurts the most. So this is the thing that you need to be careful of, because GraphQL actually allows you to do that.
Yes, and speaking of measures, it's basically like the nested data you get. Like you get a customer, then you get cars, from cars you get transactions, and you
can go like very deep there.
What do you do about it?
So you optimize. You simply forbid doing those queries. So you can add some different restrictions. You can add validation to those GraphQL queries. So if there are more than 3 nests, you can tell no. You can do those type of things.
Also, have you encountered N+1 problem with GraphQL? Because just whereas on
it does happen if an object refers to an object that refers back to this object. So it can happen, yeah, if you query that. So it's you can create that.
Have you encountered yourself on?
We haven't encountered that yet because as I mentioned, we're not in production with that yet. So we'll see. I'm sure we will encounter that.
Yes, I am asking because we run GraphQL in production.
Yeah.
And this is something that we've been struggling with for quite a while. Well, we managed to solve it before we went to production. Actually, there is this, was it like a batch loader or data loader pattern that basically you implement loader classes that gets all your requests from like whatever your request is, it gets all the kind of models or fields, and then kind of before it resolves them, it kind of makes decision
validates
how do you query this stuff.
Okay.
Actually, we are using data loaders with a custom caching solution.
Okay. Okay, so you're already there, and then
Okay. Good to know.
Actually, I have a question. How do you use this caching? I mean, do you have
Custom built. Yeah, it's custom built caching. Yeah, it's not. We're not using this GraphQL built-in caching because you don't have control over it.
You run it on Java stack, do you?
Yeah.
Okay. This like out of the box tool for Java setup, are they really good, or like how much of custom code you had to write up around it?
Tons.
Okay.
Actually, it's very underdocumented, the whole Braid feature, and I had to investigate and adventure everything myself.
So that's why it has taken us 6 months.
Okay.
And you still recommend it, right?
Yes.
Until we get it to production.
It's rollback.
I mean, you can keep throwing money at your AWS account, but there's always a limit, right? Okay, yeah.
Also, now, like between a front-end and back-end or app teams, is it much less dependencies, or is it still kind of waiting?
Yeah, that's the beauty of it. That's actually one of the reasons I didn't mention it earlier. That one of the reasons why we did it is that app teams actually now get to decide what they want and when they want and how they want it. So this actually gives quite a lot of freedom. And if there are like small changes, I want to show this field, or I want to remove something, then it's a lot easier to do for the app devs. So that is one of the biggest
benefits already, or
yeah. We I mean, they are not in production, as we said, but we see the benefits.
Okay, I have a question. If there was no GraphQL and Braid, what would be your second best go-to decision to address this problem?
So probably I would go with fully RESTful, in that sense that everything is nice and strict, not the mayhem that we have today. And then probably AWS own API gateway, not the dedicated.
You would still stick to AWS API gateway.
Yeah.
All right, and any more questions? Okay, then I also have another one.
Hi.
We do not recommend using GraphQL in production. What companies, what businesses, what cases would you not really, under no circumstances, recommend using GraphQL in production?
I don't. To be honest, we are doing banking and we are using it, so I don't know anything worse than banking to use it in. So yeah, everything else is simple. There are a couple of days, I think, how much easier would it be to build Facebook? It would be so much easier. But yeah, then again, next day it's never boring. So to be honest, I don't know. I don't know what company shouldn't be using that. Maybe very image heavy something, video streams probably not gonna work very well.
There was a comment.
You mentioned this 10 version support. What's the time frame of the support?
So we are doing a release every 2 weeks. So one release every 2 weeks for the apps because of
version out so fast.
Oh, we have an amazing team.
I mean, usually it's lingering, let's say, 2-3 years. I mean, people don't upgrade.
We have a force upgrade built into the app. So if we want, we can push the latest version and tell everyone to update if needed. So they can't do anything. They open the app and they say, I must update, so they must. But to be honest, that is a pain because of the iOS release, and Android is nicer. Android usually the app update actually pops up in your store when it's updated, but iOS the distribution takes so long, so it can be like 3 days when there is this released version and when it actually shows in your app store. So that there are some caching logic there that needs to be invalidated when you actually want it faster. But it's ridiculous. So that's why we are doing every 2 weeks this release, because of iOS, because of the process that it takes to get it approved, and then it takes another couple of days to actually reach the customers. So it's a pain.
All right. More questions? No? No? Really? Okay, so who uses GraphQL in production as well? Or who are working on delivering GraphQL to production in their companies?
That's why these people are here.
No one really.
Yeah.
Who got curious about it now? Today's talk. Okay.
Good enough.
Yes, good enough. I mean, there's like 5 teams. 5 teams across Tallinn alone. That's very good.
That's a win.
Jonas, thank you so much. Awesome.